Alright, so next concept we need to cover is solving formulas and equations. Concepts are still the same, except that we might be solving for a y and there may be an x in there. Pretty useful concept when you're dealing with equations and you want to solve it for y because you're really good at putting it in slope-intercept form and graphing it. And so it's an essential skill to have. So again, if you're trying to solve it for y, let's get the y by itself. So let's move the 3x to the other side. Subtract 3x from both sides, because it's combined with addition in a sense. It's an added 3x to a negative 6y. So subtract 3x. Again, not always do you have this. So 10 minus 3x. And then negative 6 times y, negative 6y. So we divide by negative 6. And so technically you could leave it like this without any problem. But I'm going to simplify this so you get 10 over negative 6. And then negative over negative is going to leave positive 36x. And so then I'm going to simplify those fractions. 10 over 6 both have a 2. So that's negative 5 over 3. Now, the negative was in the bottom before, but then I wrote it on top. Notice that it doesn't matter, because they both end up with a negative. Think of it as just a negative 5/3. Don't think of it as 10 divided by negative 6, but a negative number in the end. 3 over 6, both have a 3 in. I wrote 1/3, but I meant 1/2. And so you have negative 5/3 plus 1/2 x. So either or one of these. If you're graphing it, this is going to be more beneficial because you have your y-intercept, number without the x, and your slope, the one with the x. Next one's a little trickier because we're trying to solve the equation for y, but there's a y here and there's a y here. So first thing I'm going to do is still get the y's on the same side. So subtract 5y. 2xy minus 5y. And if you remember, we've been doing things like, actually x plus 3. If you have things like this, it puts a 2 into each one of these. It's called the distributive property. The opposite of the distributive property is factoring, and so we're going to factor this because it both has the y, both parts have the y in it. So factor the y out, and so then you have 2x left minus 5. This is the first kind of factoring you ever did. A lot of you, once we think factoring, only think, oh, it's got to be 2 and 2 and an x and things like that. But the first kind of factoring just pulled out the common factor. So now that we have one y, let's get it by itself. Y is now connected with multiplication to this 2x minus 5. So how do you get rid of a multiplied 2x minus 5? We divide by 2x minus 5. And so we're just going to leave it as y equals, that canceled out, 14 over 2x minus 5. And that's our answer. We've gotten the y by itself. Now, why do you have to be able to do this? We've got formulas, all of science, a ton of math involves formulas with multiple variables, and it's a lot easier to go back between. So this formula, we've got degrees Fahrenheit to degrees Celsius. And if we knew what 72 degrees Fahrenheit, let's plug it in for F. 72 equals 9/5 C plus 32. So notice the 32 is what brings it back to 0, right? Fahrenheit, freezing in Fahrenheit is 32, where freezing in Celsius is 0. And then the 9/5 is, it's almost off by a scale factor of 2. But and so Fahrenheits are smaller than Celsius degrees. The clothes are dry. Very good thing. Don't know if you heard the buzzer, that's the whole reason. So if we subtract 32, we get 72 minus 32 is 40. 9/5 C. And so how do you cancel out a 9/5? Well, you can divide by 9/5, but really the same thing as dividing by 9/5 is multiplying by 5/9. So, multiply by 5/9, and you get 5 times 40, 200/9. And 200 over 9 is 22.2 degrees. So, what if you needed to do that a bunch of times? It wouldn't be as functional, it wouldn't be very time efficient if you plugged in repeatedly for F and then had to solve for C every time, because what you would do every single time is subtract 32 and then multiply by 5/9. And so it's a lot easier if we solve for F first. Solve for C first. So F, if we subtract the 32 first, F minus 32 equals 9/5 C. So then multiply through by the 5/9, and I'm just going to leave it as such because it makes it prettier with the fractions to first subtract 32 and then multiply by 5/9. So if you plugged in our Fahrenheit 72 minus 32, you get 5/9 times 40, you get 22.2 degrees Celsius, and then you're done. Congrats. Solving formulas with variables, piece of cake. Do the same thing you would with just regular equations.